The slab is casted at the same time the beams are casted. We don't do it like this, that is the beams are casted today and on the top of it the slab will be casted tomorrow. Slab and beam are casted at the same time. The formwork for the beam is provided and on the top of the beam, the slab, the concrete is poured for both of these parts at the same time. And if concrete is poured for beam and slab at the same time, it is called as monolithic construction. So we always do the monolithic construction. Secondly, suppose this is the slab and this is the beam. So slab is lying on this side. Suppose the beam is over here. The slab is on this side as well as slab is on that side also. What happens is that the reinforcement for beam is like this. And reinforcement for slab goes into the beam like this. So reinforcement of the slab goes into the beam and reinforcement or bars in the beam are extended into the slab. So as such, the reinforcement of slab goes into the beam and bars in the beam are extended into the slab. This joint is a sort of rigid joint. So these two together, or these two, that is slab and beam, act together over here. Now if I consider the three-dimensional view of this beam, this is the beam suppose. So beam is running from this end to that end. I am just sticking to this beam. So column is on that side, column is on this side. The beam is running like this, and it is the span of the beam from that column to this column. Slab is on this side, slab is on that side also. Now what happens is that because the reinforcement of one component goes into the other, a rigid joint is formed. Now if this beam is supported over here and over here, means on this column and on that column, and as the load is acting on it, load from the slab is acting on it, and because of which it bends, it is going to bend in this manner. But see, the bending happens in this manner. Slab is on which side? The compression side or tension side? Now slab is usually provided near the top of this beam, isn't it? Slab is on this side. Slab is on this side also. Isn't it? Slab is over here. So slab is on both sides. And there is a fixity between the beam and the slab. Now if beam tries to bend, what will happen? The slab will also have to bend. Because these two are fixed to one another. There is a rigid type of joint. So if the beam bends, the slab will have to bend. And again, if the beam tends to bend, slab will have to bend, but slab will offer a resistance to this bending. Actually, which member is going to bend? The beam. But slab also offers the resistance to this bending. Means slab helps, slab assists the beam in resisting compression. And this joint action is called as flange action. So flange action is nothing but if beam and slab are cast together and if the reinforcement of one goes into the other, a rigid joint is formed and the compression of the beam is resisted by the slab also, or slab helps the beam in resisting this compression. This joint action is called as flange action. If the slab lies on both sides of the beam, the flange looks like as if it is a T-section, isn't it? It will be like this. If the end of the building is there and if the beam is at the end, and if the slab lies on only one side, it will be an L section, isn't it? So L section or T section takes place under these conditions. First, monolithic construction. Second, slab should lie on the compression side of the beam. If the slab is on this side, lower side, means it is on tension side, so it will not take any part in resisting the tension. So slab helps the beam in resisting compression. No, slab. Some part of the slab, some length of the slab. See, joint is found over here, but steel in the slab is running throughout this span. So up to certain length. Joint is a rigid joint, but still slab is also the part of that joint. So some part of the slab remains stiff because certain movement takes place over here. It is a rigid type of joint, isn't it? So see, if it is a fixed beam, the bending do not start from here. It do not start from here. It starts from a certain distance from the support. Why? Because the fixity is there and some movement is there. So some part of the slab, that is some length of the slab, acts together with it. So some length of the slab on this side, some length of this slab on that side. Both of these lengths act together with this beam, and this length is called as breadth of line. How to get this breadth of line is again, or you will have to adopt certain formula for that. That formula is given in IS 456. But in order to have a T beam, slab should be on both sides of it, isn't it? And in order to have L beam, slab should be on one side. But three conditions are necessary. First is slab should be, the casting should be monolithic. Second, slab should lie on compression side of the beam. And third, the main reinforcement in the slab should be perpendicular to the span. Main reinforcement in the slab should be perpendicular to the beam. So three conditions, remember these three conditions. Monolithic construction, slab should lie on compression side of beam. And third, main reinforcement in the slab should be perpendicular to the span of the beam. So what is a T or L beam? T किंवा L beam म्हणजे काय होतं? Because of the monolithic construction, because of the slab lying on compression side of the beam, the slab helps the beam in resisting compression. Isn't it? And a rigid joint is formed in between the beam and the slab because of the steel from the beam goes into the slab and steel from the slab goes into the beam. Isn't it? So because of this, such a rigid joint is formed, and because of which the slab acts together with the beam. हे लक्षात आलं तुमच्या आता T आणि L. Now I am drawing certain plan. Tell me which one is T beam and which one is L beam, which one is the rectangle. Now the slab, the plan of a certain building is like this. Now I am naming the beams. Suppose there are number of columns over here. Now suppose this is beam B1, B2, B3. B4, B5, B6, B7, B8, B9, B10, B11, B12, B13, B14, B15, B16, B17. So 17 number of beams are there. Suppose a monolithic construction is there. Now what does this indicate? It is one-way slab. One-way slab means the main reinforcement is along this direction. So for all these spans, for all these slabs, main reinforcement is along this direction. What does this indicate? So main reinforcement is along both the directions, isn't it? Now if I consider beam B1, B2 and B3, B1, B2 and B3, are they going to be L? Now the slab is only on one side, so these beams can be L beams. The question is, are they L beams? Now slab is on one side, but the main reinforcement is running parallel to the beams. It is not perpendicular to the beams. So it is not perpendicular means there is not a sufficient rigidity in between the slab and beam. हे जी जर मेन reinforcement यामध्ये गेले असती तर एक rigid joint form झाला असता. But it is not possible over here, and these beams are neither L beams nor T beams. These are rectangular beams. These are what? Rectangular. But see, here B1, B2, B3 are rectangular, but on this side B15, B16, B17 are they rectangular? Because one of the main reinforcements is perpendicular. So these are what? L beams. Now what about B4, B5, B6, B7? मला 12:30 सकाळी क्लास असतो मला 8:30 ते 8:30 कुठं मी इथं FC रोड आहे हां मी जरा इथं वाजले